Okay, let's see what we can do here. So we've got something that at first glance, if you don't look closely enough at it, it looks like it could be one of those situations where you have like the same slope and all of that, and so it's going to either be parallel or they're going to be the same line. But if you look closer, you should see that the y coefficients are not the same. So this might actually wind up being something different. So we're just going to go ahead and plot it. So let's start with this one. So we're going to use x and y intercepts for these. All right, because it looks like they're going to work out. So remember, for your x-intercepts, you make y equal to 0. So I'm going to write that. Y is equal to 0. And for your x-intercepts, you make x, or for your y-intercepts, you make x equal to 0. So let's do my x-intercept first for this first one. So that would be x plus 3 times 0 equals negative 3, which means we have x is equal to negative 3. So I'm going to go over here to negative 3. I'm going to put a point, and we're in good shape. All right, my y-intercept, I'm going to make x equal to 0. So I'm going to have 0 plus 3y equals negative 3. So 3y equals negative 3, divide both sides by 3, and you should get y is equal to negative 1. So we'll go over here, we'll put if it'll stop glitching and go where I'm trying to do it, here, and we go through. Yeah, that's not terrible. All right, not perfect, but pretty decent. All right, now, so for my second line, for x minus 3y equals negative 3, my x-intercept, all right, just know that y has to be 0, is going to be the same. I'm going to wind up with x equals negative 3, because you can see that if I zero out this term, you're just left with x equals negative 3. So let's erase that mess I just made. And I don't have to plot that point again, because it's right there. Right, that's where it is. So, very good. Now, for my y-intercept, that's where we get something a little different, right? So I'm going to make x equal to 0, and I have negative 3y equals negative 3. If I divide both sides by negative 3, my y-intercept is now going to be positive 1. So I do have two different lines here. We are just kind of lucky in that they meet at the x-intercept, right? They meet right here. So the solution for this one is the point negative 3, 0, right? And that's kind of cool. That worked out pretty well. If I put this into my top equation, I would get negative 3 plus 3 times 0 equals negative 3, and that obviously works out because that goes away. And if I put it into this one, I get the exact same thing, right? So they both work out, and that's our point. So it's a slightly odd case, but it is consistent and independent because we get one solution. All right. Last one for this overall lesson here, and then we are all done with this lesson 1. All right? And just so you guys know, solving these things by graphing is really, it's problematic, as you can kind of see. It's not very precise, and it's slow, and so we're going to be looking at some other ways to solve these. But it's good to have this graphic representation of what this looks like, because then it might make more sense to you. All right, so let's do this one first. X minus y equals 2. So I think both of these equations we're going to graph using intercepts. All right, so for x minus y equals 2, my x-intercept, if I make y 0, I have x minus 0 equals 2, which means x is 2. All right, so we'll go over here and we'll put a point on 2. And then for my y-intercept, if I make x 0, we have 0 minus y equals 2. So we have negative y is equal to 2, which means that when I multiply by -1 to get y positive, you get y is equal to -2. So here we go. Here's my line. And let's put this through it. That looks, I think that's the best one I've done yet. Not too shabby. All right, now this one, 3y plus 2x equals 9. So for my x-intercept, we're going to have 3 times 0. Now, because they're flipped around, right? They moved x and y to try to be obnoxious. So this goes away. You get 2x equals 9. So divide both sides by 2, and you get x is equal to 9/2, which is, for those of you who prefer decimals, is 4.5, right? So I'm going to go over to 4.5, and I'm going to put a point right here. Okay, now for my y-intercept, I'm going to make x equal to 0. So we're going to have 3y plus 2 times 0 equals 9. So 3y equals 9, which means that y is going to be 3. So divide them both by 3. So that's way up here. Okay, and let's connect these. So these are going to be, let's see, let me do a little thinking here really quickly. Y, so negative 2/3, so down 2 over 3. So it should go about here. That's a really, really poor line, but that's the idea, right? And it would continue to go this way, right, like that. So this is what we get, and it looks like that's our intersection. So it should be hopefully, if we did this right, it's the 0.31. So let's put this into both of our equations and see if it satisfies both of them. Because the thing is, when you check your solutions on these, you have to check them in both of the equations, or it doesn't work. So if I put this in the first one, it's just 3 minus 1 equals 2, which is 2 equals 2, so that's good. In the second one, we have 3 times my y, which is 1, plus 2 times my x, which is 3, equals 9. So we have 3 plus 6, and 3 plus 6 last time I checked was 9. So it works out. That's my solution. This is consistent and independent. And I apologize because I don't think I double checked our solution for this last one. Yeah, I didn't. But, oh, you know what? Yeah, I did. What am I talking about? Anyway, going senile here. So I hope this is helpful to you guys. Good luck with these, and just know that as obnoxious as this is, there is hope on the horizon, because pretty soon you'll be able to solve these algebraically and you won't have to monkey around with this. So thanks for your effort and good luck.